All right. I'll prepare Marco's slides right now, but do you want to say a high intro maybe?
Yes, Marco, I'm leading AI efforts at MetaMask, both on like innovating the wallet and agentic stuff that you will see soon. I co-authored the ERC 2004 that Davide mentioned, and we will briefly mention as well during my talk. And I co-founded like 3 weeks ago Agent Zero, which is an open source AI lab, which is focused on making progress on what we will discuss today. Here we are. So, we talk a lot about the progress of models, but actually a lot of the progress happens when you connect the models with something outside, and what just happened with OpenClaw and Moldbook is the proof of that. So in a sense, we already have like very intelligent models that are totally disconnected from arms and legs, and so a lot of like the value comes from there. And we're still talking about just one model, just one agent. But and this is like connect models to tools, which is like exposed a lot of like the improvement of efficiency and actual use case that we have seen in the last 18 months for sure. Then when we talk about connecting more models or more agents, you have something called cross-app memory. So cross-app memory is basically when your booking agent suggests cheaper hotels because it knows from the banking agent that you don't have like a lot of money that month. That's cross-app memory. We're still like at the very beginning for like huge privacy implication, but it can have like a huge impact in we connect the models. Cross-user memory is basically when your agent doesn't suggest a specific restaurants because it knows from like interacting with multiple other users that that restaurant is bad. We are still at the very beginning of this. And the ultimate layer is when actually you have like a full agentic economy where different players have economic interaction around the sharing of data and services that could better achieve your goal. And that's the topic that I want to talk about, agentic networks. And this is crucial because like agents and agentic networks are important like societies are for humans. So almost all the discussion that we do, and for sure like till January, because like on January 28, ERC 2004 went on mainnet, on January 29, Moldbook was launched, but we're still really at the beginning. And so just imagine a humanity without societies to think about what we are seeing now for agent. Let's start from like a basic framework, and then let's discuss a few interesting directions that we made progress on and we will make progress on in the last few months. The layer one is how agents get aware of existence of other agents. We take it for granted just because it's very easy for us, for humans. So if I just walk in the street, I can like find a shop or talk to people. And because reality acts as like a potential discovery layer that is of course accelerated by digital catalogs and all the technologies that humanity create to help humans reaching out to other companies or other humans. Nice. But how does this look like for agents? So discovering other agents and deciding if trusting them or not. This will happen with centralized catalogs, centralized solution, decentralized solution. The second is when I like found this agent and I need to start talking to this agent, we have this layer which is like, to me, not super interesting from a technical perspective. All these like wrapper schemas, MCP is very popular, A2A. But then there is a third layer. So I finally found the agent. I have this wrapper. I know how to send the message, but what do I actually say, right? These are like the communication techniques and behaviors. And for now, like we're not dedicating a lot of attention to this, just because agents speak as we do, just because they have been post-trained on multi-turn human conversation, right? And so it seems obvious, but it's not, because we are not humans. We are like profoundly different capabilities. And finally, the learning loops. So basically, reinforcement learning and all the many different techniques of reinforcement learning that you can do to optimize the result or a given result given all the steps that we just went through. So ERC 2004 is focused on the layer one, and it's basically an Ethereum not Ethereum actually, it's now used also on, we will soon launch soon on Solana. It's a protocol to use blockchains as distributed registries to have discovery, which is permissionless without going through a centralized intermediaries, then can, like in the world of apps, take a fee or sensor reality. It's like the equivalent of me walking outside and talking to I want without needing permission or pay somebody. And this is the identity registry. Then we have a registry to enable agents to give feedback to other agents and humans to give feedback to other agents. We make the data public, and then it's up to you to compose that and create your own reputation algorithm. So the big opportunity, since agents are so good in aggregating data, is making the data public so it doesn't become a moat. And soon we will launch validation that leverage basically trusted execution environment attestation to make you confident if you trust the code that is running in the TE and the TE vendor that the agent is behaving correctly. So this is like in this space. What's next? So something interesting in this level and also in the learning loops that we are starting working on is called Explorer Agent. So humans take, I think, like 20 years of their life to learn, to like form their own opinion on the other people, understand if they need to trust them, form their opinion on what the other people can do. This is like a complex capability. And what we discovered, like in the early days of ERC 8004, that went to mainnet 1 month ago, I mean, it's one of the most popular initiatives now in AI and crypto, but is that it's not easy at all to spot which are the good agents. Exactly as, by the way, for humans, it's not like trivial to understand which company should they trust, which, and so a big challenge that you will see the industry focusing on in the next very few years is, you can create a benchmark, you can develop the capabilities in multiple ways, is how can an agent understand why and why should trust another agent, what the other agent is for. And of course, you can't just trust the description, right? So it's like a human going to other human and asking something. The other said, yes, I'm the best engineer in the planet. Okay, thanks, here's the job. This is not how it works, right? And we don't think this a lot, but it's a capability that it definitely needs to be developed. And so from a more ML perspective, you can also, when you create a process that enable an agent to spot this in other agents and to find and use all these signals to achieve this, you can, of course, do RL on this. Shifting to the step of the communication behavior and techniques. So as we said, agents are very different from us. They have a deterministic memory, they think faster, by far faster, and differently, and they also like can do math. So for many problems, the huge degree of freedom that we have, that we use in our language, is actually a limit, or is not necessarily the most efficient thing to do. So imagine like a jargon agent, or the name is a joke, imagine this as a capability, but an agent that based on the specific problem that is tackling can just use like a different language, which is not like imitating me. I'm a human, but like it's not necessary. And to achieve what specifically? Higher efficiency, so fewer tokens to achieve the same goal, or less data disclosure, like for example using like cryptographic protocol, as you will see in a second, more security, more precision, and in general giving a given benchmark a better performance. And just to give some examples, of course the most straightforward example is literally a jargon. So you can do that like mid-training. Mid-training is more difficult, but post-training and context engineering, of course. So you create like, you have less degree of freedom and you create your simplified language. It can be more schematic to just achieve what you need to achieve given that specific business context. You can also do that with like deterministic adapters as output guardrails that are deterministic in some cases, not on all. Or, so for example, humans, I have just one mouth, so we can just have one conversation at once, right? But if you create, and you can vibe code and start playing with that in a few hours. You can vibe code an orchestrator that like that shared context among different conversation, and you can, of course, you have some dependency in a conversation, some ordering, but other things cannot be ordered, and you can just go 10x faster. Agents could do that. So there is a lot of innovation at the interaction layer that you can do. Or that's pretty interesting. So also humans, when I start answering, from the very first words, you can already like learn a lot compared to like, like if I start with no, I don't think you from the very first. So it's basically the quantity of meaning is like the reverse of a lambda function. It really goes down very fast. So why, instead of what like we have been coding now, that you wait the end of a turn, right? Why not just starting answering back and starting the counter inference after the few tokens, right? What I'm saying, again, takeaway is that there is like a whole world of innovation that can happen at the comms layer, at like level number 3, communication techniques and behavior. Finally, yes, that's what we discussed. Finally, protocol agent, and here we have made some progress that we presented 3 weeks ago. Coherently with what I just said. So humans can't use cryptography in their daily life just because it's too complex. And we just can't do math, it doesn't come to our mind. But there is a lot of strong cryptography that is like around since the 80s that could help. So instead of, if we're doing an M&A of an oil company and spending billions, instead of like signing an NDA to understanding which territories we're both operating and extracting oil, we could use private set intersection and just like know which are the common common elements of two sets without revealing the same sets. Same if we're like scheduling a meeting, a coffee, and we don't want to share our own agenda. We just don't do that because we will feel like crazy, right, as humans. And, or zero knowledge proof, there are like plenty of primitives. Imagine an agent, a model, and that's the paper that we just published and that brings interesting results on this. Imagine a model that can primitive selection in an everyday context, personal context, doing like small talks at the grocery store or in business context, spot which specific primitive can be cryptographic primitive can be helpful for that case situation. Second, it convinces the counterpart, because I need to convince you that for this M&A deal we need to use like this private set intersection. So you have soft skill involved. It can implement the protocol properly in terms of steps, also like complex protocols. In doing that, it can use them, do the math correctly, and we have a cryptographic Rust calculator that we created on purpose for the project. And finally, even if the security model of this project is honest but curious, adversarial part is crucial, so I should be able like to not disclose what I shouldn't disclose. And these are like a bunch of use case. So yes, I want to like to report to file an anonymous report to my like I don't know, in my community, proving that I'm part of that community, but not saying who I am. The list is really long. This is super useful in life. We just don't do that because we are humans. And you can check in the paper, but the results in terms of performance on the open weights model that you tuned with a data set created on purpose on this are very interesting. So it's not just theory, it works. This model can, on this specific problem set, can do better. And finally, and I hope with this like pragmatic direction that I think really give idea of how much we can do at the agentic network level, and not just connecting tools and improving models. And we will do it in the next few years. The message is that we are really just at the beginning. What happened again at the end of January for our community of ERC 8004 and OpenClaw is like a good example. And if you want to like join our efforts, we are like we'll start giving hacking grants from probably next week to progress on the 3 areas that I've mentioned with Agent Zero. We are looking for partners working on that, also funders. So like feel free to get in touch. Thank you. Yes. If there is any question, I would be happy to. Are there any questions? I hope you liked my mid-journey. My favorite one, I think, is the Explorer one. Thank you for your time.